All right, hi guys. I'm going to show you how to do stoichiometry problems 1 and 2 on worksheet 2. So a couple notes before we get started. One is that make sure that your work and your answers have proper units. That's really important for helping to get these kinds of problems right. And also make sure to start with a balanced reaction because that's how stoichiometry works. Stoichiometry only works with a balanced reaction. So none of the reactions in this worksheet are balanced, so you'll have to go through and balance them for yourself. So let's check first with this first one. Lithium, there's one lithium on the left, one lithium on the right. So we're good on lithium. So one oxygen on the left, one oxygen on the right. So we're good on oxygen. There's two hydrogens on the left, two hydrogens on the right. So that one's good. And one bromine on the left and one bromine on the right. So that's also good. So this reaction actually is already balanced because everything is in a ratio of 1 to 1. So we checked the balancing for that one. Let's check the balancing for this one. There's two carbons on the left, only one on the right, so I'll try and solve that by putting a 2 here. We've got 4 hydrogens on the left, 2 hydrogens on the right, so I'll try and solve that by putting a 2 there. Now as for oxygens, we've got 2 on the left, and 4 plus 2 is 6 on the right, so we can solve that by putting a 3 right there. And now we're set up to solve these problems because we're starting with balanced reactions. So one thing to note about these is that all of them are mass to mass. That's expressed here in grams, starting in grams and ending in grams. And that means that all of the problems are going to follow a pretty similar procedure. So for example, if we're thinking through the process for solving this problem, we're going to start with grams of lithium hydroxide. Next step is to convert to moles of lithium hydroxide. After that, we're going to convert to moles of our destination, of our own unknown. So that's lithium bromide. And then finally, we'll convert those moles of lithium bromide to grams of lithium bromide. And as for how you solve that, you're going to start with your 10 grams of lithium bromide, or sorry, lithium hydroxide. We'll convert from grams to moles. So moles of lithium hydroxide goes on the top because that's what we want. Grams of lithium hydroxide goes on the bottom because that's what we want to get rid of. And 1 mole of lithium hydroxide is equal to some number of grams. So that's the molar mass right there. And you'll have to calculate it to solve this problem. If you look it up on the periodic table, you'll find that lithium has a molar mass of 6.94, oxygen is 16, and hydrogen is 1. So if you add those together, you get 23.94. So 23.94 grams of lithium hydroxide is equal to 1 mole of lithium hydroxide. Next step is to convert to moles of lithium bromide. So that goes on the top. Moles of lithium hydroxide go on the bottom. And now this is the mole ratio step. And you'll get that mole ratio from the balanced equation. This is why we had to check that the equation was balanced. So remember, there's a 1 that's implied in front of each of these because there's no other coefficient. So 1 mole of lithium bromide is equal to 1 mole of lithium hydroxide. And then final step is to convert to grams of lithium bromide using the molar mass. So grams went on the top because that's the unit we want. Moles goes on the bottom because that's the unit you want to get rid of. And 1 mole of lithium bromide is equal to some number of grams. Bromine has a molar mass of 79.9 grams per mole, so you'll add that to the molar mass of lithium, 6.94, you'll get 86.84. So 6.84 grams of lithium bromide is equal to 1 mole of lithium bromide. And then when you do that math, let's see what we get. So times 10 and divided by 23.94. Our answer is going to be 36.27 grams of lithium bromide. All right, so now let's take a look at the next one. So the next one's actually going to follow the exact same process. You'll start with grams of ethylene. Then you're going to convert to moles of ethylene. Then you'll convert to moles of carbon dioxide. And finally, you'll convert to grams of carbon dioxide. So here's what that looks like in a calculation. There's your 45 grams of ethylene. After that, you'll convert to moles of ethylene. So moles goes on the top. Grams goes on the bottom. Now we'll have to calculate the molar mass just like we did before. Every carbon, so carbon has a molar mass of 12, hydrogen has molar mass of 1. So that's 24 plus 4, so 28 grams. So the molar mass of ethylene is 28 grams per mole. Next up is the mole ratio step. So moles of ethylene go on the bottom. Moles of CO2 go on the top. And then looking at the mole ratios in the balanced equation, there's a 2 in front of CO2, and there's a 1 in front of C2H4. So that gives us our mole ratio. And then the final step is to calculate moles of carbon dioxide, or sorry, calculate grams of carbon dioxide. So grams is what we want, that goes on the top. Moles is what we want to get rid of, that goes on the bottom. And then 1 mole, here comes molar mass again. The molar mass of CO2, if you add it up, is 2 times 16 from the oxygens plus 12 from the carbon, comes to 44 grams per mole. And now when you do that calculation, you get a total of 44 times 2 times 45 divided by 28, 141.4 grams of CO2. And if we compare this calculation to the previous one, you can see that it actually has the exact same steps. So here's the step where we converted to moles. Here's the step where you use the mole ratio. And here's the step where you convert back to grams. Again, using the molar mass, because you always use the molar mass to convert between grams and moles. All right, so that's how you solve problems 1 and 2. Stay tuned for Dr. Kopf to show you how you solve problems 3 and 4.